Hello, this is Governor Roberts, Governor of Room 13. I'm here to give you the latest news on COVID-19. I have my chart over here of the number of cases compared to the month. And as you can see, cases are on the rise. When you have a curved graph, things are increasing exponentially, which is the topic of today, exponents. The reason why things happen exponentially, especially with germs, let's say you have germs on your hand and you shake two people's hands. Well, now those two people have the germs. Let's say they shake two people's hands. Now, instead of two people having the germs, we have four people. And if they shake two people's hands, now we have 8 people. That is an exponential function. A, B, C, D, F, G, H, I, J, K, L, M, N, O. It's an exponential function. That would be doubling everything every time. So that's like 2 squared, 2 cubed. I'm doubling it every time. It increases exponentially. So now we're going to do our lesson on exponents and learn some of those rules by doing expansion.
Welcome to Intro to Exponents with your Governor of Room 13. This is one of my favorite topics, and I can't explain why, but I just really like it. And then when you get to high school, I don't even know if they teach logs anymore, which are the opposite of exponents. I loved logs, and if you talk to anybody who's done logs, they're going to tell you they hated it. But that's probably why I'm a math teacher, right? So let's check this out. I'm gonna go through this pretty quick. You're probably gonna catch on pretty quick. Then I'm gonna go back and I'm gonna redo these questions using the shortcut, which is more like I'm just using the rule. So what you're going to do is you're going to listen for a couple and pause the video and then try a couple on your own and unpause the video. I'm not going to keep telling you to pause. You pause it on your own and try stuff on your own, unpause and check your work. So we're doing exponents. Exponents is repeated multiplication. The little number up top tells you how many times to repeatedly multiply the base. So without me actually knowing anything new that's 8th grade math, let's use our elementary school math and expand it. It's 4 times itself 3 times. 4 times 4 is 16, times 4 is 64, but you can use the calculator for that. And if I'm going to put this in the calculator right from the get-go, 4 to the 3, you use the caret button. Caret button is for any exponent you want to use. It is right here. You won't see that caret on your screen. You'll see it move up to the exponent. You press 3, now you're still up top. If I was going to do anything else, I would go to the right and get out of it first. Press enter and you get your 64. So 1/2 squared means 1/2 times itself 2 times. You could use the caret button, or you could use the squared button. Since squared is so common, it has its own button. So I'm going to do parentheses because I saw that on my paper and I like to make it identical to the paper. So 1 down 2 to the right, parentheses, and the squared button is located really close to the caret button because they're similar, and the calculator puts similar things together. And then I'll press enter and it will tell me the 1/4 because 1/2 times 1/2 is 1/4. Okay? So let's do 7 squared divided by 7. So we're going to expand. When I expand, I try to simplify. Anything divided by itself is 1. So this comes out to be 7. So if I'm going to do this in the calculator the way I see it here, I'm going to type in the fraction. I'm going to put in 7 squared, go to denominator and put in 7. And we're going to discover what the rule is a little later. So that's 7. What's the exponent there if there's nothing written? How many 7s are there? There's 1 7 there. So we would press N over D, 7 squared down, and then 7. That's what I put that in the calculator. Okay, so let's do backwards for a second. If I have expanded form, how many times did I multiply those 2's? 4 times. How many times did I multiply the 3? 2 times. I didn't combine anything together. I'm not doing 2 times 3 because they're not like bases. And then I could put this in the calculator. 2 to the 4th, get out, times 3 squared is 144. I can do this too. 2 to the 4th times 3x squared. Okay, those are calculator buttons. I'm doing everything on the calculator right now. All right, so maybe you want to pause and do a couple instead of watching me. 2 to the 5th. 1, 7. Put the 1 there if you want. 2 to the 3rd. I can divide 2 divided by 2 and get 1. I can write that 1 down. Or I cannot write that 1. Oops, I forgot a 2. Not now. If I don't write the 1s down, it's not going to be a big deal because I still have numbers left. And when I multiply by 1, I get back what I started with to begin with. So it's okay if I don't write those 1s down this time. If everything was gone, I would want to leave the 1. So I got 2 times 2 is 4 times 7 is 28 divided by 3. Is that what I have here? I'm going to check my answer in the calculator. 2 to the 5. I'm going to show you something wrong in a second. Divided by 2 to the 3. Okay. If you did this in the calculator, especially if you have an older calculator, this is how you would put things in an older, it would be wrong. Because in this equation this way, the only thing that's getting divided by 2 cubed is just the 7. If I go and write this, I'm going to insert. If I want to divide the whole top, then I got to put it in parentheses. Which is why I really would have avoided all that to begin with and pressed the fraction button. When you press the fraction button, you don't have to worry about it. There's no 3 here. Excusez-moi. I got confused with that 3 and put a 3 down because I was going too fast. That's why we don't go fast. So it's 28. And really the best way would be to put it in as a fraction. Oh, but I want to go over the rules. So I'm going to skip this for now. Okay? I'm going to pause my own video. You guys do these 2 and then unpause. Alright, I made a little mistake, so you might see a little bit of white out here. So I expanded this out. I divided off one of the 5s on the top and the bottom because that makes 1, and I divided off one of the 4s. And over here there's nothing to divide off. I just kept expanding it. In standard form you get this answer. I would like to rewrite this again, the simplified version, in exponential form because it's going to help us come up with the rule. So when I divided off stuff, how many 5s are left? I have 2 5s left. Put it down here because we're going to go back and write the rule. And then I still have 3 3s and I don't have any 4s left. Well, think about how I went from this to this and what the shortcut or rule might be. And we'll come back later and write that down. So over here, there was no division in this problem. Let's, let's group up like terms, okay? Because I have to have like bases. I'm not going to do 3 times 2 is 6. I'm trying to simplify it in exponential form. So I'm going to write down the 3 and the 2. And we're going to write down how many 3s we have. I see 1, 2, 3, 4, 5, 6, 7. I had to write it on a new line because I ran out of room. And I see 1, 2, 3, 4, 5 2s. Maybe you can think, how did I go from this to this? And I left room to write the rule. Okay, so let's do H, which is a little different because I have letters in it. Is there an exponent on the 2? You're saying no, you don't see one. But it's kind of like a denominator, even though you don't see a denominator. There's still a denominator there, and that's 1. How many 2's are there? There's 1. Let's write that in. And 1, 3. So it's 2, and the squared belongs to the x. It does not belong to the 2. If I wanted it to belong to the 2, I'd group that together with parentheses. Okay, so there's 2 x's. X times itself twice. There's 1, 3, and x times itself 7 times. 1, 2, 3, 4, 5, 6, 7. I don't have to write a times in between letters. It's implied. I don't have to write a times in between a letter and a number. It's implied. So the only thing you can put in the calculator is numbers. Do not put X in the calculator. If you tell me you can put X in the calculator, you can. But for everybody, the X might be a different number. Mine X is stored as 0, which isn't going to help me with my question. Do not put letters in the calculator. At this point, we do not have a use for it. So let's summarize. What do I see? I can do 2 times 3. I get 6, and then I see X times itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Maybe you can figure out the rule by now. Okay, let's work backwards. Here it is expanded. What was it in original exponential form? I would have originally still had the 6 and the 2 here, but I would have summarized 1, 2, 3, 4, 5 x's times itself as x to the 5th. The y had nobody to go with, so I just copy it, and at the bottom it was x times itself 3 times. So that would have been the original question. And then I can do 6 divided by 2 and get 3. Anything divided by itself is 1. There's 3 ones there. I see 2 x's left over. X times itself twice is x squared, and 1 y left over. Maybe you see the rule. All right, then I got the last one down here. We're gonna expand this. Ooh, this might get ugly. I'm gonna put the 2's here, and then if you don't mind, I'm gonna kind of layer this. 1, 2, 3, 4 x's. 1, 2, 3, 4, 5 y's. Oh, there's a 12 in here. There's 3 z's. I always write my z's with a line in it so they don't get confused with the number 2, which you could see over here. And I got 2 z's over here, 4 y's, and an x. Now, anything divided by itself is 1, so let's go. 2 divided by 2 is 1. I still have a 12 left. All right, there's 1x down here, which we can divide off with 1x over there. So how many x's are left? There's 3. I don't care what order this is in. It doesn't have to be right on top of each other like it was with the other ones, because commutative property of multiplication says I can change the order if you feel better about it. So I got 2 z's here. I can cross that off with 2 z's here, and there's only 1 z left. And yeah, I just did z's before y's. So what? Multiplication's commutative. It's so cool. It's all right. So I got 4 y's here and 4 y's here. That leaves me with 1 y left. There's nothing left in the denominator, but I'm not dividing by 0. When everything divides off, this is when it's important for me to actually write the 1. Or I just write this without being in fraction form. Okay, so let's go back. Did you figure out the rule? How did I go from 2 to the 5th divided by 2 to the 3rd and get 2 squared? Where's the 2 come from compared to 5 and 3? What am I doing with the 5 and the 3 that makes it come out 2? That's right, I'm subtracting it. So this one has a division. The 2 came from doing 5 to the 3, take away 1. I'm only going to subtract the exponents. There was a 1 here that you didn't see. Maybe we should write it in. I'm only subtracting the exponents when it has a like base, because I'm not crossing off a 3 with a 5. I'm crossing off a 5 with a 5. So it must have a like base. There was nothing to go with the 3 cubed. That's why it got copied, because there was no like bases. But over here we had a 4. The top one was a 1, and so is the bottom one. And when you subtract, you get 4 to the 0, which divided off, which is going to be a rule for another day, because anything divided by itself is 1. So this actually is just a 1. This is all that I have. Okay, so check this out. How did I go from, I got 3 to the 7th, right? And I had 3 squared and 3 to the 5th. So where did I get the 7 from? adding the 2 and the 5. And I didn't combine it with the 2's because they're a different base. So here, where did I get 2 to the 5 from? Because I had 4 2's and 1 2. Over here, we did the coefficients. These are the numbers in front of a letter. We call them coefficients. We multiplied those. And then since these have like bases, I do 2 and 7, which makes 9. And if you don't remember these rules, when in doubt, expand it out and you'll be fine. So that's how we get 6x to the 9th. Over here, you're going to divide the coefficients, and division is subtraction of exponents when you have like bases. Okay, these are the rules. And it's not that hard to remember. Division is subtraction. They're both lines. Multiplication is addition. When you multiply like bases, you add the exponents. When you divide like bases, you subtract them. So over here, we did the coefficients together, and then x to the 4th with this x to the 1, so 4 minus 1 because we're dividing, y to the 5 minus 4, subtraction because we're doing dividing, and then z had a 3 up top, take away a 2 on the bottom. And that's how we got this answer. And I made it by the bell. Okay, maybe you need to replay it. There's plenty of helpful YouTube videos on Intro to Exponents, and there was one that you were supposed to watch before this lesson. Okay, you're going to have practice problems on the next page. If they don't have any letters, you can totally do the whole thing in the calculator and not even know the rules. But I highly encourage you, even if you do the entire thing in the calculator, try and do it without the calculator so you can learn the rules and be ready when I give you letters, because you can't put the letters in the calculator.